Hello and welcome to Module 3 in our Python series. Today we're going to be writing scripts working with numbers, and then of course we'll take a look at some of the Python integer methods that are both built-in, okay, as well as available through the math module. So let's begin with the scripts. The first one, write a script to print out the first 100 even numbers. Let's go straight to our Python shell. And when we have numbers like this, let's say 2, 4, 6, 8, 10, there is a certain pattern, right? Every subsequent number is the previous number incremented by 2. So we can use that in the logic, right? So we could have something like this. For x in range, let's say 0, 10, right? And then we could say print x plus 2. But will that complete, will that give us the required outcome? So for the first number, it will, considering x is 0. But what about the second number? When x is 1, this will print 3. So you'll see if I go through with this, right, then I just get the numbers in sequence, as in consecutive numbers, right? That's not what I want, so I need to change this a bit. So what if I said print x plus 2 and then I added x back again? Right, so 0 plus 2 plus 0, that's 2. 1 plus 2, 3 plus 1, 4. Right, 2 plus 2, 4 plus 2, 6. And you see that it seems that it will work. Let's try that out. And there we have our even numbers. Okay, the next script is to print out the odd numbers. Right, so let's go back to the shell, right, and we say here for x in range 0, 10, right? But now if we said print x plus 2, it will print 2. So what if we said print x plus 1, right? So instead of saying x plus 2, we said x plus 1. And of course, then we added x again, right? Just like we did here. Let's press enter and see what happens. And you see we get our odd numbers, right? So now we can go ahead and write the script. So let's start idle. Start a new file. And we're going to specify how many numbers we need. So for x in range 0, n, right? Because we don't know what that number of numbers will be, print x plus 2, right, plus x. And that's all. So now we can run this. We need to, of course, make sure to save it. Now we can run it. Even numbers, let's ask for 10. And we get 10. Even numbers 20. And we'll get 20. Okay, so you see that that works. Now, for odd numbers, it's the same. So let's just change this to odd. Right? The only difference is we need to change this to 1. And of course, the file name is even numbers. Let's change that. So file, save as, and let's make this odd numbers. Right? Save the file, and now we can run it. We can start a new shell and odd numbers 10. We have our 10 odd numbers, right? Odd numbers 20, and we have our 20 odd numbers. So the next script is to print out a given number of prime numbers. Okay, so let's say the given number is 10. We've tried out with 10 numbers, and if that works, we can then be sure that the logic will work for a greater number of numbers. Now, what exactly is a prime number? Prime number is one which has two factors only, right? The number itself and 1. So is 1 a prime number? No, it's not, right? Because 1 has only one factor, which is itself, right? So now let's think about the logic. So if we talk about prime numbers, we have 2, 3, 5, 7, 11, right? So I'm just putting in a comment sign there so I don't get errors, right? So this is an example of the prime numbers, and you can see that each of them has two factors, the number itself and 1, right? So let's see that, like I said, the number of prime numbers we want to be printed out is 10. So we'll keep a prime number counter here, and we'll initialize it to 0, and we'll have another variable which will be initialized to the first prime number. Okay, and then of course we need to now have a loop which will ensure that we get the 10 prime numbers. So while prime num counter is less than 10. Okay, clear so far? Now what do we do in the loop? For each number that we go through, we need to check for divisibility, right? So what we'll do is we'll have another number here, let's just call it loop number, right? And this number will also be initialized to the first prime number. Okay, and then we'll have one more loop while loop num is less than num. Okay, and within this inner loop we check for divisibility. So if num percentage loop num is equal to 0. So if the number is divisible by loop number, then what does it mean? That that's not a prime number, right? So then we have to break out of this inner loop. So break, right? Else we increase loop number by 1. Okay, 1. And then we go back and check whether loop number is still less than number, and we continue to check for divisibility. Now, if loop number is not less than number, which means we have to exit this loop, right? So now we specify what happens when we exit the loop. Now here we will have a check to see if this loop was exited because divisibility was found to be true, or because loop number is no longer less than num. So if loop num is equal to num, right, which means in effect that we didn't find any case of divisibility, then this is a prime number, right? So we'll say print num, right? And that's the end of basically what we need to take care of for this inner loop. Now what about the outer loop, right? So after this line, the next statement should be, we need to now check for the next number, right? So we'll increase this num by 1. Right? And then of course this will go back into this loop. But remember, there's a check here while prime number counter less than 10. So we need to increase that prime number counter somewhere. Where should we do that? We do it after this line, right? So here we'll say prime num counter plus equal to 1. And then of course we need to increase num by 1. Okay, so I hope you understood this logic. So now num will increase by 1. We'll go now to the outer loop and check is prime number still less than 10. Then we'll initialize loop num again to 2 and we'll check while loop num is less than num, we'll check for divisibility. If we find divisibility, we break, right? And when we break, we check if loop num is equal to num. If it is, then we print that number out. That would be a prime number, right? And we add 1 to prime counter. Otherwise, we just increases. But remember, this statement will be executed irrespective of whether we exited the loop because this condition no longer holds or because factors were found or divisibility was proven to be true, right? So this num will increase by 1 and then we'll go back into the loop again. So now just to take concrete examples, first let's run this code and then we'll go through what exactly is happening with the numbers. Okay, so here you can see I've got my prime numbers and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So now just to run through, so the first time num is 2, loop num is 2. So in effect, basically, this loop will not be entered into at all. So we come here, loop num is equal to num, right? Num is 2, loop num is 2. We print 2, right? Prime counter increases by 1. We have 1 prime number. Then we increase this to 3. We go and check, is prime num counter less than 10? Yes, it's 1. Loop num is initialized to 2, while loop num is less than now 3. So 2 is less than 3, yes. If 3 divided by 2 gives us a remainder of 0, it doesn't, right? So we'll go here to this line, or rather control will move to this statement, and then loop num will be increased by 1. We'll go back into the loop, right? When we go back into the loop, we'll check while loop num is less than num, right? So is 3 less than 3? No. So we come here, is loop num equal to num? We'll print 3, right? Prime counter increases by 2 or increases to 2, and then we have num plus equal to 1, which is now 4, right? Then we go back into the loop, is prime num counter less than 10? Yes, it is 2. Then loop num now is initialized to 2, while loop num less than 4. If 4 percentage 2 is equal to 0, meaning if 4 divided by 2 gives us a remainder of 0, yes it does, then we break. Is loop num equal to num now? Loop now remembers two numbers 4. So it's not a prime number. We just increase number by 1. Right? And so we go to 5. And you see how this is now working. Right? So now we can go and put this into the script. Right? So new file. Let's just call it prime numbers. And there's going to be a parameter coming in specifying how many prime numbers we want to be printed out. We have a prime number counter equal to 0, right? And we have a number equal to 2, right? While prime num counter is less than n, right? Okay, so now what do we do here? We have our loop number equal to 2, and then we have our inner loop while loop num less than num. Okay, now we check for divisibility. If num percentage loop num equal to 0, right? So we found divisibility there, break. Else loop num plus equal to 1, right? And then we go back into this loop to check. Now what happens when we exit this loop? When we exit the loop, we will check if loop num is equal to num, right? Then we print the number, because as we know now that would be a prime number, and we add 1 to prime number counter, right? And then as we said, the number has to be incremented by 1 to be checked again for whether it is prime or not, right? So I hope this is clear. Again, you could come up with different logic, right? There's just not one method to do things, so we need to keep an open mind. Okay, so now we can run this. And we need to save the file. Okay, and let's say prime nums 10, and then we have our prime numbers. Try prime nums 20, and you get the 20 numbers, right? Okay, so now I'm just going to close this. Moving on to the next script. Write a program to find the square root of a number. Okay, so you may have learned different methods of finding a square root, but you may also know that I can do something like this. So if I say 4 raised to 0.5, I'll get 2. If I say 5 raised to 0.5, I will get this number. Now Python has their own method. You need to import the math module. Okay, and then we can say print math dot square root. I'm going to take 5 here. And you see I get the same number as I got here. And of course, we're not going to write a script just to put in this one line. What we're going to do is we're going to write a script to print the square root using what is called the Babylonian method. Now, the Babylonian method, as you may know, is used in calculators. That's how calculators arrive at the square root. Okay, and we need to look at the steps. There are certain steps involved, right? So we take a look at that now. So these are the steps to finding the square root using Babylonian method. First, we find a number, meaning we look for a number. So we have a loop here which has its square closest to the number we are finding the square root for. Okay, so we are looking for x, and of course the number we're finding the square root for is num, assuming, right? Then we find the average of x and num of x. Now why are we doing this? Because if we say x, right, we could be sort of getting an overestimate in terms of, the closeness to this number. And if we say num divided by x, we could be underestimating. So we take an average of both. Okay, then we repeat the steps, that is this step, for 4 iterations using the average, right, in every subsequent iteration. So we'll calculate this average, and then we have a loop, of course, and every time we go into the loop, we'll be using the average we arrived at in the previous iteration. Okay, that's what this means. And then we'll arrive at the square root. So now let's go and write that code. And I'm going to go now straight into idle. So let's start a new file. Okay, and we'll just call it square root. And there's going to be a number coming in as a parameter. Right? Now I'm going to be writing comments here so that you can understand what is going on. So first step, or step 1, okay, now how do we do that? We need a loop, of course. We'll have x equal to 1, right, and we'll say while x raised to 2, that's x squared, is less than num. Okay, and then we just increment x. So that's that first step. Okay, then now we need to go to step 2. Okay, so x being this number, and then of course the num divided by x. So here we have our step which says average equal to x plus num divided by x, and that whole thing divided by 2. Remember, we're taking the average, right? Then we go to step 3, where we'll have a counter which will be counting up to 4, and then while, so this should be actually, this is not within this loop, right, and while counter is less than 4. Okay, what do we do within the loop? Average equal to, remember we have to take that previous average, right? So average plus num divided by average again. Okay, and that whole thing divided by 2. Right? And then we can, in this loop, print average just to see how we arrive at the final value. And then once we're out of this loop, we print plus, if you're doing a concatenation, we need to change that to a string. So str of num plus, so I hope you got what we're doing. You're just following the steps. Find the number, right? A square is close to the number, and then of course step 2, we find the average, and then we repeat 4 times. So let's now run this. We need to save it. Okay, and let's run this in another shell. Let's try square root of 5. Why is this happening? You see, it says here your program is still running. Do you want to kill it? Yes, we do. Because here we have not increased counter by 1. Okay, the moment you see that the loop is continuously running, it should occur to you that within the while loop we have not incremented something. That's the only reason why that loop will go on and on. Because it becomes an eternal loop, right? Counter is always going to be less than 4 because we're not increasing it here. Okay, run. Let's try square root 5. And there you have it. Right, so you see how it's going to the approximate value, right? And a more precise approximation is this. This is, as you will see, exactly what we had here, right? Okay, the spacing is a bit awry, but I'm sure you can change that. Write a program to print out the sum of all numbers in a list. Now this should be pretty easy for you because we did in the last session sum up string elements, remember, in a list. So let's go straight to idle for this. Start a new file. Sum of numbers, and list 1 is going to come in as a parameter. Then we can just say for x in list 1. Now we need to sum them up, so we need somewhere to store that sum, right? So first we'll say sum equal to 0, right? And then sum plus equal to x, right? And then of course print sum is comma sum, and that's all. We run this now. Sum of nums, let's supply the list, so L1, and then of course we call that function. So sum of num and send in L1, and there we have the sum. Okay, so the next script is write a program to print out the product of all numbers, and that is the same as the previous one, right? So we can change this. First of all, we'll say prod of num, and now we'll have to say product, and we can't have it as 0 or then the result will be 0. So change that to 1, and here we say product, and then this symbol should be the asterisk, right? And then of course here product is, okay, and product, right? Now we need to save this file because this is sum of num, so let's save that as multiplication, and now run this. right? So provide the list and call the function. What's the name of the function? Prod of num and L1. Okay, what's the problem here? We have said product, whereas it should be prod. Okay, so let's just change that. Run. And we can just copy the same list. Right? And then, okay, there seems to be a space there, and therefore that's syntax error. You need to make sure there's no spaces, and there we have it. Okay, so coming to the next script, write a program to find the maximum and minimum of a list of numbers. So for this, I'm going to take you to the shell just for a minute. So if I have a list L1 equal to, right, by looking at it, I know what is the minimum and maximum. But how do we put this into code? Right? So I can say, for example, maximum equal to 0, for example. And then I can say, you know, if any of these is greater than this one, then let max equal to that number. So when I run to these numbers for x in range, for example, at the end of this, we should have the maximum number, right? It will be in a loop. For minimum though, can I say minimum equal to 0? I can't, right? Because then 0 will always be the minimum. So for minimum, I will take L1 of 0. Got it? Right? And then check in the loop if any of these is less than the first element. Okay, let's write this code now. So here we need a max num that will be equal to 0, and then we need a min num which will be equal to list 1 of 0, right? Let me say for x in range 0 comma len of list 1. Now we should say minus 1, right? Because if I have the list of, let's say, 2, 3, 4, 5, although I have a length of 4, for the range this is 3, 0, 1, 2, and 3. Okay? Right, so for x in range this, what do we do? If list 1 of x greater than max num, right, then max num should be equal to list 1 of x. Similarly, if list 1 of x less than min num, then min num should be equal to list 1 of x. And then we'll just print out the result. Print maximum comma max num, and then print minimum comma min num. Right? Let's run this now. Let's start a new shell. List 1, and then we call the function, and there we have it. Right? Moving on. Write a program to print the Fibonacci series. Now, what is the Fibonacci series? The Fibonacci series is something like this. it's 1, 1, then 1 plus 1, so 2, 2 plus 1, 3, 3 plus 2, 5, 5 plus 3, 8, 8 plus 5, 13, and so on. So you see here there's a pattern, right? How do we write the logic to print out this series? We could have something like this, right? We say, now this is for a given number of numbers. So let's say we want 10 in the series. Okay, so we could say x comma y equal to 0 comma 1. Okay. And then we could say for z in range, or let's say k in range, okay, 0 comma n, which would be, let's say, 5, right? Now we need to again develop some kind of a formula, right? So we can say z equal to x plus y. So first time be 1, right? So print 1. Okay, so let's say we say z equal to x plus y, right? So print 1. Then we can say x comma y equal to y comma z. What are we doing here? Okay, first of all, I hope you understood this statement. So in Python, you can write something like this: x comma y equal to 0 comma 1. At the end of execution of the statement, x will be 0, y will be 1. Similarly here, x will have the value of y and y will have the value of z. So at the end of this, x will be 1 and y will be 1 as well. So we'll print out 2, right? Then x will be equal to y, right? Remember what z is? 2. So x will be 1, y will be 2. And then we print out 3 and so on and so forth. So let's now go and write the script. File, new file. Okay. Let's call it fib. Okay, and we're bringing in the number of numbers we want to print out. And we say x comma y equal to 0 comma 1, right? And then for k in range 0 comma n. Then we said z equal to x plus y, right? Print z, and let's stay in the same line. So n equal to, or we could leave a space between the numbers, right? And then what do we do? X comma y equal to y comma z, right? Let's run this and see what happens. Run. Let's just call it fib. Okay, I'm going to start a new shell. Let's say fib of 10. And you can see I've got 1, 2, 3, 5, 8, 13, 21, 34, 55, and 89. Right? And you will see that each of these is a sum of the previous two. Right? Now you may say, okay, I haven't got the first one, but of course we'll have to print that out. So you can safely do that after this line. Right? That's Fibonacci. Moving on, write a program to find the LCM of 3 numbers. Now again, how do we do this in code? Mathematically, I'm sure you can do it. Right, so let's go ahead and write the script. For this one, I'm going to go straight to idle let's start a new file and call this find LCM, and that's going to be a list coming in of 3 numbers. Let's find the maximum of that list. Okay, and now we start what is called an eternal loop. While true, make sure that you have a condition that breaks out of this loop, or this loop will be eternal, which means your machine will go into hang mode. Okay, if max num percentage, remember we are finding least common multiple. So if max num percentage list 1 of 0 equal to 0, meaning it's divisible, and max num percentage list 1 of 1 equal to 0, right, and max num percentage list 1 of 2 equal to 0, right, then what do? We print LCM comma max num. Of course, we have to break from this loop, so we'll have to have a break statement here, right? If we have found the LCM, else max num plus equal to 1, and so max num will go on increasing until it comes to a number which is divisible by all 3, right? So let's run this now. Let's call that find LCM. Okay, let's provide the list equal to and find LCM of L1. So there's a mistake here. Let me just maximize this so we can see, right? Max of list 1, we should see, right? Okay, so let's run that now. And we can take that same list and paste that here. We just need to make sure there's no space there, right? And then find LCM, provide the list, and there you have LCM is 120. Okay, now moving on to the next script, and that is write a script to find the GCD of 2 numbers. Now how do we do that? So again, I'm going to go back to idle and we'll start a new file. Let's call this find GCD, and that's going to be 2 numbers, right? So A comma B. For this one, we're going to be using a function called max. So let's say I say max of 23 comma 34. Okay, return means 34, right? So I can use this now in the code, right? So here I can just calculate the difference. Difference equal to max of A comma B, right, minus min of A comma B. Okay, then I can say while diff is greater than min of A comma B. Then we say diff minus equal to min of A comma B. Right? And so that loop will go on, right, as long as difference is greater than minimum. Okay, once this condition doesn't hold, then we come out and we have the calculation of the GCD equal to min of A comma B minus diff. Right, and then print GCD comma GCD calc. Okay, now we run this. Find GCD. Okay, and let's provide the numbers. Say find GCD of, let's say, 12, 20. Oh, there's a mistake in my spelling here. So GCD calc, run. And let's call that function again. And you have GCD 4. Now you can double check this. And this is what I wanted to tell you earlier. So here we are. We can import the math module and then say print math.lcm, for example, of 12, 20, 24. Okay, and we get 120. Similarly, we can say print math.gcd of 12, 20, right? And we get 4. Now the next script is write a program to print out the factorial of a number. Right, so what's a factorial? It would be something like this. If I said 5, factorial would be 5 into 4 into 3 into 2 and into 1. Okay. Now how do we put this in code? We could either decrement the number or we could start from 1 and increment up to 5. Right? So now let's go and write the code. Okay, new file. And we'll name this factor. Okay, so let's just call it fact. And the number is going to be coming in through that parameter. Then we have a variable x equal to 1 and we have factorial equal to 1. Okay, and then we say while x is less than or equal to num, right? And factorial into equal to x. Right, so the first time x will be 1, factorial will be 1 multiplied by that x. Remember that value is stored in factorial. The next time will be 2. So factorial multiply equal to x will be whatever is already in factorial multiplied by x and so on and so forth. Right? And of course, we've got to increment x. When you're doing a while loop, you need to make sure that you increment. For the for loop, remember, it's automatically happening, but for the while loop, it is not. Right? And then of course, we just print factorial of, right, comma num, comma factorial. Right? That's all. So now we run this. Let's save it as num factorial. Save. And let's call that function the number. So let's try 8. Factorial of 8 is 40320. If you want a smaller number to check, check 5. Factorial of 5 is 120. Okay. Now moving on to the next script. Write a script to determine if a given number is a desarium number. Now what's the meaning of a desarium number? A desarium number is something like this. Let's say I have 175. If I take 1, I raise that to the power of its position, which is 1. I add to that the second digit raised to the power of its position, which is 2. And then I take the third digit and I raise that to the power of its position, 3. And I will get 175. That's a desarium number. Now this is not the same for all numbers, as you will see. You can try it out. It works only with certain numbers, and therefore those are called desarium numbers. Now how do we determine if a number is a desarium number? So thinking of the logic, we first have to get the length of this number. To get the length, remember, we can't just say len of 175. That will give us an error because we cannot mix int and string. Len, the function, is only applicable to strings. Right? So we'll have to convert that to a string. So if you say len of str of 175, right, then you get 3. So when we have 3, then we can actually say, if we say 175, okay, percentage 10, we'll get 5. So we have the last digit, we can raise that to the power of this length. Then we can reduce the length by 1, right, and we can see 175 flow division 10. What will that give us? 17. Right? And 17 percentage 10 will give us what? 7. So now we have the second digit and we can raise that to the power of length, which is reduced by 1, so it will be 2, and so on. So we can use this now in our code. Let's go now to idle and write down the code. So new file, I'm going to call it desarium or just desar. Okay, and it's going to bring in the number. Right? Now, of course, we need sum because remember we have to add up those. We have to add these up, right? So we need a variable to store that. And then we say length equal to len of str of num. So then we get the length. Right? Now we store this number in another variable y because we are going to be using it for the different calculation, that is the flow division, etc. Okay, so we store that number. And then we say while num is greater than 0. Okay, that is the same number that came in. And then within this loop, we say remainder equal to num percentage 10. So as you saw, we'll get the pi, right? If you're talking about 175, then we can add that to the sum. Sum plus equal to rem raised to the length, right? Then we reduce the length by 1. Then what do? We say num divide of low division equal to 10. And now you see that the value of num will change, and therefore we have to store it. Once this is done, this will go back into the loop. And so we'll get the remainder, like we saw, right? We said num divide equal to 10. What did we get here? 17, right? And then 17% 10, so we'll get 7. That's going back in this loop. And so we continue that process. And when we come out of this loop, we'll check if sum equal to num1, right? So then the number and the sum that we got are equal. Then we can say this is a desarium number. Print str of num1 plus, now when you're using concatenation, you need to convert this to string. Okay, I can't just say print num1 plus. Okay, str of num1 plus is desarium, right? Else print str of num1 plus is not desarium. Okay, so now let's run this. Run save it. Okay, I'm going to start a new shell. So now we say desar num, and let's pass in 175, and it is desarium. Try it with another number. Let's say 134. See, not desarium, and you can actually check that out. You know, 1 raised to 1 plus 3 raised to 2 plus 4 raised to 3. What does that give us? You can in fact do it here itself. So 1 raised to 1 plus 3 raised to 2 plus 4 raised to 3. And you see the answer is 74. Right? Okay, so that's about desarium numbers. Moving on. Write a script to print a pattern. Now, what exactly is this pattern? It's this pattern. Okay. So, how do we print this pattern? If, for example, let's go to the shell to figure this one out. Remember the pattern? It's like once, then it's printed twice, thrice, 4 times, 5 times, etc. Okay. Now I can't say print 1 1 time, then print 1 2 times, and so on. That's not what we want. Right? We need a loop. Okay. So can we do this with 1 loop, or do we need 2 loops? That's what we need to figure out. And so we can do something like this. Let's try it out here first, and if it works, we'll put it into the script. For y in range 1, 7. Why am I saying 7? Let's go back to that pattern. I need 1, 2, 3, 4, 5, 6. Okay, so 1, 7, right? And then let's say I have another loop for z in range 0, up to y. So in the first case it will be 1, then it will be 2, and so on. Okay, so up to y, right? Print 1, okay, comma, we need to make sure we are on the same line, end equal to, right? And then we just want to go to the next line after printing, so we say print. Okay, let's see what happens. And you see we get that pattern. Right, so I hope you've understood this logic. This outer loop is going to take care of these number of rows, right? And then this inner one is going to take care of how many times this is printed. So for the first time, it's going to print 1 how many times? In the range 0, y. So it's going to print it 1 time. Then y will become 2. So it'll print it 0 until 2. Right? So print it twice, and so on and so forth. So now you can put that into script. File, new file. Let's just call it pattern. There's no parameters coming in here. For y in range 1, 7. Then for z in range 0, y. Print 1, end equal to the null. And then of course we have just a blank print statement to go to the next line. Okay, let's run this. We have to save it and just call it. And there we have that. Okay, you can try different patterns. You can probably try printing out a heart, for example. Now the next script we need to write is determine if a number is a palindrome without conversion. Now what do we mean without conversion? It means without converting the number to a string. Because if we do that, then we can use slicing. Right? So this is to be written without using slicing. So how do we do that? Let me just take you to the shell. So let's say I have a number 175624. Right? Now in order to determine if this number is a palindrome, I have to reverse the number and then check whether it reads the same, right, in reverse. But how do I reverse the number? Right? Without using slicing. The clue lies in this 175624. If I say percentage 10, what do I get? 4. So I get the last digit, right? And then I can say 175624 floor division 10. So what does that give me? 17562. Right? If I take 17562 and again I do a percentage 10 on that, what do I get? 2. Right? So I can use this now in my code. Okay. So let's now go ahead and write that code. We start a new file and let's call this check palindrome. Okay. Now of course that number is going to come in, right? Here we'll say reverse number equal to 0 while num greater than 0. So the loop is going to be changing the value of number. We need to therefore store the number in another variable before we change its value. So while num greater than 0, after storing it, here we'll say remainder equal to num %10, right? Then we'll say reverse number equal to reverse number multiply by 10 plus remainder. Now I hope you understand this. So currently reverse number 0. So 0 multiplied by 10 plus the remainder. What will happen in this case? We'll get 4. So reverse number will have 4, right? Okay, then what are we doing? After this, we'll say num flow division equal to 10, right? And this is why we needed to store the number before we do this calculation, because when we do this, then the value of num is going to change, right? Remember, it's going to be 17562, for example, right? And then we go back into the loop. We check if number is greater than 0, remainder equal to num %10, right? And then we will get 2. And then we say reverse number is equal to 4 into 10, right? Plus remainder, right? 2. So we'll get 4 and 2. And so we'll be reversing the number, right? If you look at it, we will be reversing the number. We get 4, 2, and then we'll get 6, 5, 7, and 1. Okay. Now, after the number is reversed, right, which means we come out of this loop, we check if reverse number is equal to num, or num1 rather. Remember, num has changed its value. So equal to num1, print, we can say num1, or if you want to do concatenation, then str of num1 plus is a palindrome, right? Else print str of num1 plus is not a palindrome. Okay. Now of course we need to save this file. So we can just click on run. Right. And now we can run this and see if it works. And let's say 175624. Okay, it's not a palindrome, right? If we say check palindrome 989, 989 is a palindrome, right? So you see that this works. Moving on, write a script to determine if a number is odd or even. Here what we're going to do is we're just going to use a simple rule, and so I'm not going to actually write that script, I will just tell you the rule. The rule is, for example, 4%2 will always be 0. Take any even number and %2, it's always divisible by 2 basically. So remainder is always 0. But take 5%2, 5 is not divisible by 2, and so is not any odd number. Right? So you can use that. I'm sure you'll figure out the logic. Right? So I'm going to leave that with you. Right, so now we're going to look at the different functions that Python provides. We start with absolute. If I say ABS of minus 345, we'll get 345. So that's like the maths modulus, right? Binary, if I say binary of 97, will give me the value in binary preceded by a 0b. CHR, we've already seen. CHR of 97 will give us lowercase a. Div mod will give us quotient and remainder. Okay, so if I say 25, right? So we'll do the division and give us a quotient which is 4 and remainder is 0. We've already seen enumerate. Float will give us a float value of an integer, and integer will give us an int value. We've seen those. Minimum, I could say min of 97, 65 or 5, let's say 54, 34, 3 or 2, right? And give me the minimum. Similarly, I can say maximum, right? And that will give us a maximum. Odd, we've already seen, right? So odd of lowercase a will give us 97, right? Odd of lowercase b will give us 98, right? Then we have pow, which is related to the power of. So pow, let's say 4, 2, and that will give us 16. 4 raised to the power of 2. You can do any power. You could say 4, 3, right? And that will give us 64. Round, how does round work? So I could say round of 34.45, 2. So 2 decimal places, in which case I will get the same value. But if I said round of 34.45, 0, I will get 34, right? If I, however, I said round of 34.47, 0, then what would I get? 34 again. Why? Because this is 4, 4, 7. Now let's try round of 34 point, let's say 6, 7. If I say 2, then I'll get the same value. But if I say 0, then I'll get 35. So you see how the round function works, right? Then we have sum. So I could say L1 equal to 23, 34, 2, 4. Okay, and then I could say sum of L1, and I will get the sum. Right? So remember, we did sum of numbers as a program, but you have a function to do that. Okay, so now moving on, we have the math module. Math.ceil gives you the smallest integer greater than or equal to the number. So let's say, for example, I import math because we need to import that module before using it, and then say print math.ceil of 45.47. Okay, say 46. The smallest integer greater than or equal to x. Let's try math.floor. .47, and we'll say 45. Okay. Math.gcd, math.lcm. So I think we already did this where I showed you how we could use these functions, right? Math.product. Okay. So let's say L1 equal to 23, 4, 5. Print math.prod, okay, of L1, right? And you get the product of a list. Similarly, you have factorial and square root, right? But of course, as I said, if you're asked to print the factorial of a number, right, without using the built-in function, then you know what to do. So with this, we are done with today's session. In the next session, we will work with tuples and lists, specifically double dimensional lists, and we'll also work on our project. Right, so till then, take care, stay safe, bye.